Hey, good evening, and welcome back to this particular course. And today we are going to see uses of pandas and numpys and why these all libraries are mostly and widely used in data science community. And today I will tell you why pandas and numpy stand out as compared to the different libraries and what they bring different to data science in general. So let's begin, and I will give you an overview on what is pandas and what is NumPy. And once that happens, I will go through all the demos and the set of codes that I have executed in order to introduce to you. And let's start. So why pandas for data science? Specifically, why pandas? Why not something other or something else? So first of all, pandas is a library that brings everything all together in one place, wherein wide variety of functions can be performed. And pandas is inherently means the underlying library it uses is NumPy, and these both packages goes hand in hand when you talk about data science and the computational things that is required for data science, be it analytics, or be it execution of things, or maybe filtering, or maybe other transformations that is required, or pre-processing that you're doing, or something that has to do calculation or processing that is in your pipeline before you model or maybe reach to a certain decisions. So let me explain you why pandas. So as I told you earlier that it is one of the most complete package that provides a wide variety of functionalities. Those are what you can say that those are the generalized standard functions that are required for proper data scientist or maybe analyst who is into analytical things. So that is the reason why data scientist prefers pandas. And I'm telling you that pandas, and I'm exaggerating pandas a lot, because with pandas itself you can do pretty much everything, but numpy is what pandas use as an underlying library. So I will also tell you about the numpy and why it is different and why it is important to understand the importance of numpys. Okay, so first of all, NumPy is different from normal list operation. Like, why we cannot use Python list uh, for holding any data set or maybe anything as in comparison with NumPy. Okay, so normal list is like a collection of objects. So those objects cannot be those objects can be single data type or multiple data types, which can vary your execution time, and is not that efficient when you talk about that. Secondly, it does not hold your data set. I mean, object 1, object 2, object 3 are not continuous. So maybe you define object 1 at some random point, and maybe the object 2 is referred or been used at random point, and then you came to a point where you define a list, a Python list. So what Python list is just the address for that object and address to other objects. So it is collection of objects and the addresses that it holds. So it's never going to be a continuous set of objects, right? So in memory there are many objects that are not continuous. That is the reason why Python lists are not that great in efficiency as compared to NumPy arrays and NumPy objects. So what NumPy does differently is like it stores similar kind of data. Like if the NumPy array is defined as integer or base of 64, so then it will hold certain type of data types. So what that happens and what happens with that, what advantage we get with that is that because it all defines or generalized in same category, the operations you perform on that are much more optimized, because you know what you're going to get. There is no random things coming out of that set of list or array, right? Whereas in Python list that is not possible. You can hold anything in that Python list. So that is the reason why NumPy arrays are much more faster compared to Python list. And NumPy arrays store everything continuously. Means one object has one address, and then the next object is has the continuous address. So once you fetch first element in the list, you will get every elements in the list continuously. It's that way built up. And third point to mention is that because NumPy and Python NumPy works means is built on C and C++ libraries, code architecture which is underlying under NumPy, that makes everything true native to the operating system. So actually you don't have to understand this much all, because it is not going to help you anywhere, but you should be aware of the things that yeah, NumPy is faster, and because of this all reasons it is faster. So this is what NumPy is. Actually, NumPy, you don't have to study NumPy as a different thing, because you would never use NumPy. Personally, I will tell you that you will never use NumPy as a primary library for doing your all data science actions or performing any things, because NumPy itself is used in pandas. So if you are using pandas, it's automatically everything written in NumPy. Means wherever it is uh, interacting with in the the CPU or something like that. So I will tell you why pandas uses NumPy. So here I went to this pandas documentation, wherein you can find out that you can see here the NumPy. These are the dependency. Means what happens in libraries and packages is that if you install one library, maybe that is the case that to execute those libraries, means the code within that library, you need other dependencies also. Means if you want to implement one thing, it requires other things to be installed simultaneously to use that particular library. So in this case, pandas requires NumPy, Python dateutils, and PyTG. It is a time zone based library which returns the time zone and all that, I guess. So these three libraries are the dependencies from Python perspective for pandas installation. And this you don't have to install manually, it automatically gets installed whenever you install pip install Python, or some other way of implementing Python installation. So this is how these libraries are interconnected, and you specifically never have to go and study NumPy. But in this tutorial I will just give an overview of why, means how you can use NumPy, and what all different things you can perform with NumPy's basic operations. Okay, and there are many other things that NumPy can do, but today we are just going to focus on the basics that NumPy is practically useful for data scientists, whereas all other complicated and complex operations are handled by pandas itself. So you don't have to go ahead and dig into that things which are not necessary enough. So here we are going to execute set of commands, and I will just give you an overview, like what is means why we are executing these things and what it means, right? So first of all, we will just import all the libraries that we are going to use. So NumPy as NP, this is the standard conventions that we use and we follow. So first of all, I will just show you what is NumPy arrange thing. Like NumPy arrange is a NumPy operation of function that takes two inputs and arranges the set of numbers in according to these numbers. Okay, so I will just show you. So this, as I told you earlier, that shift tab helps you to bring this particular thing in Jupyter. This thing provides you the information about how the functions works, and what all the parameters we have to pass to the function, and accordingly you can definitely go and look ahead for what all customizations or specific hyperparameters you have to provide. So first input is start and second is the stop, and if you don't name start and stop, it will automatically assume that the first input is start and second is stop, and so on and so forth. And third is a step. So what is step? Step is the amount or the number of difference between two numbers. If I hit 2 and execute, so from 0 to 20 it will create a set of numbers with difference of 2. Now I'll show you what is the output of ARR. So as I told you earlier on. So it will create a set wherein the difference is 2. By default it is 1, and you can see that, right? So NumPy arrange helps you to create a series of numbers uh, depending on the differences and much more parameters within itself, right? So this is the basic thing that you would anytime means you would require whenever you want to define things in NumPy or the list of array. You can use this particular array to create a list of variables or numbers starting from 1 to between a range with differences of two numbers with giving proper differences between two numbers like 2 or 3. You can create a difference of 3 between each number or each iteration to the next number. So it comes handy when you are looping within or creating a dummy data, or maybe you are using this things to map different things. Maybe first integer or first position is given something or something like that. It can be used to create an indexes between things. There are many use cases for this thing, but I don't think so you should really rely on this particular uh, approach. You can definitely use it, you can use it anywhere. There is no point, there is no discussion of it like you cannot use it or not, but you can avoid this whenever it is possible in pandas as well, right? So majority of the operations are similar to the pandas because NumPy library is used within pandas. So whatever you are using, like in pandas also you can find out max and mean, and it at the end within itself calls NumPy function and passes these all parameters to it. So it's not that you should learn NumPy specifically, but just to give an overview, we are going through this exercise. So as we know that this is our array, I will just execute, and you can see the digit over here. It tells the number of cell the step or the count of operations you performed. So this is 10th cell after kernel has been started. So this is the latest and updated as of now. This is last execution operation that you can say. So we will try to find out minimum and maximum. So here we just call NumPy MP and pass in the array. This is one way to execute things wherein it is correct. The minimum value here is 0 and the maximum is 19, which matches the values properly. Now there is other way as well. Just call this and pass this to the max function. That means array has a max and min object. So when you debug, you can really find out what all objects, what all properties array creates itself whenever you define in NumPy, and these all are the functions associated to this uh, NumPy array. Yes, and you can just call any of the function and it will tell you uh, what is exactly this. So item size is 4. Item size is 4. Okay. So I really don't know what item size is because we rarely use a NumPy and all those libraries. So these all options only comes when you have any value or object or whatever it is which is stored in a variable. So because I have defined AR over here, the interpreter, the Python interpreter or the Jupyter kernel knows that this array consists of these values. Okay, now keep this in mind. I will later on come to this point whenever I'm trying to get this tab functionality and I'm not able to get any options because the function or maybe some things are not being executed. In order to Jupyter knows that whether what kind of function it is and what kind of object it is and what kind of functions that object has, right? So just keep this in your mind. We will look at it later on while executing the set of codes. So you can see here the min and max values can be achieved with this function, and there are two or multiple ways to define or to get the values out of it. So you can call numpy max and you can pass in the array. So it will take array as an argument and it will find the maximum value within that array. So this way you can find the maximum within the array, whereas you can other way around also find out that array which we have defined has a max object. So when you call that max object or max function, then it returns the value of maximum value. So this is how objects and the functions works. So in similar way, mean can be found executed. So mean is nothing but the middle value or an average value of a set of values. So 1, 2, 3, 4, and 5. So mean is nothing but sum of sum of divided by number of count. So we have 4 of these, so divide by 4. So this is the mean of this list, right? And we can validate this thing with np dot mean and pass in this value matches to this value. So this is what mean is. Mean is nothing but average of all the elements within the list. Standard deviation is how much far the values are from the middle number. So standard deviation of our ARR, which of this is 5.777. So it is the deviation from average or mean. And same way median is nothing but when you arrange everything in ascending order or descending order and find out the middle value. So we can do this over here. If we arrange this in ascending order, and which is by default in ascending order because we have defined it in such a way. So what number of elements are here? 20. So out of 20 we have to find out which is the middle value. So middle value, you don't have a middle value because this is an even set. So middle values can be in between of 9 and 10. So if you divide 9 plus 10 by 2, because then only you can find the median or mean value. So whatever the mean value comes between 9 and 10 is your median for this particular group set. So in this case it is 9.5. So let's continue and we can look ahead with different operations we can perform. So as we seen earlier on that it is 9.5 as a median. So what is percentile and how can we calculate with a NumPy array? So I will just show you how we can calculate. So 10th percentile of this NP array is 10th percentile of NP array is 1.99999. Yes. So how it is calculated? That you can search for the calculations and just I will give you an overview for that. So what is 50th percentile of NP array? It is 9.5, means 9.5 is the middle ground for any value, and more than 9.5 it is above 50 percentile. Anything below 9.5 it is under 50 percentile. So when you see percentile, for example, if you give an exam and you stand at 75th percentile, so percentile means that there are 75% people who are below you. means below your marks. It's that way. So it's what it is. So 10th percentile means how many numbers are below 10th percentile, 10 value. So there is 1.9 values below 10th percentile for this thing, right? So this is how percentile is calculated. So line space is just like np.arrange, and we'll look into it how it works. So like we decide we have seen earlier on, like what is np.arrange. So this is similar with some minor nuances that is different from np.arrange. So what is it? We can just look into it. So there are more parameter to it, and it can create a list of arrays as well, I guess. So for me, it creates a list of array uh, which ranges from 0 to 500, and with number 5 means difference is between. Okay, so it says that you arrange 0 to 100 uh, numbers with only 5 numbers. Means how can we put it in this way? Give me 5 numbers from 0 to 100 with evenly spaced way. If I put over here 6, then it will give me 6 numbers which are evenly spaced within this 1 to 0 to 500. If I tell you to give me 10 numbers, and then it will space 10 numbers evenly spaced between 0 to 100. So this is the minor difference between np arrange and line space. So line space itself tells you that with what between a range how much number you want, and it will evenly space all the numbers between this 0 to 100, and it will provide you an array of those numbers, right? And array.shape, what shape is? So shape will return you the value of the dimensions of any np array. So for example, this array is one dimensional. That means there is only one list, it is not list of list. So because it is one dimensional, you don't get any number ahead of this particular thing. And I will just show you another example of shape once we are there at that juncture in this particular course. So what is reshape? So reshape is just rearranging the set of array into a matrix or something like that. Okay, so I will just reshape this array, which is our this array, in 4 rows and 5 columns. Okay, and it reshaped everything in 4 rows and 5 columns. Means 4 different list, 1 2 3 and 4. Okay, and with 5 elements within itself. So when you visualize this thing in an excel or maybe a tabular format, so there are 4 rows, that means 4 list, and there are 5 vertical columns. So that's what this way you can rearrange or reshape any list of arguments. And we can do it in vice versa as well, like 5 rows and 4 columns. But you cannot rearrange or reshape incorrect set of values. It will give you an error because the calculation does not ends up with 20 set of values, right? Sorry for minor annoyance because my phone was not on silent. Anyway, so this is the reason why it won't be able to arrange things, because the calculation and the math doesn't match up with what you're trying to implement. So 5 columns and 2 rows, and you have 20 elements. It's not possible with 5 columns and 20 elements. So 5 rows and 20 elements, 5 rows with 2 columns in 20 elements. So we have to make sure that whatever the operations you are doing on reshape or transform or all this, this parameter should match according to the array which you are trying to manipulate with. So transpose is nothing but it just how can I put it in this way? It will rotate your table with one axis. Like uh, if you are aware of mathematics, the transpose is just converting x-axis into y-axis and y-axis into x-axis. So I will just show you an example. First of all, I will just print what is the reshape table is. Okay, this is how it is: 0 1 2 3 4 5 6 7 8 9. Now what transpose will do? 0 1 2 3. So what reshape will do is that it will rearrange everything into like 0 1 2 3 4 and 4 5 6 7, so and so forth. Now let's try that. So just executing this transpose command and it will just transform everything like what we have discussed earlier. For example, 0 1 2 3 4 5 6 7, what it does is like it changes the table or transposes the table structure. So 4 by 3 array will become 3 by 4 array matrix. And now I will just print out the shape. Now it will give you the shape. So it tells you that you have 4 rows and 5 columns, which is true. 4 rows and 5 columns, and so on and so forth. So let's go ahead and see what is sorted. So sorted is self-explanatory to sort an array. So by default, we means if I execute this, you won't see any difference because our array was itself sorted, right? Now we will try to create a different array which is in descending order, maybe in other format, and we'll try to sort that. So now np.sort. So let's begin with random array, and it will give you a sorted array like what it is defined to. And keep this in mind that it will only sort in ascending order. You won't be able to sort in descending or any specific order. So this is to be considered whenever using this particular operations. So now we will come to this thing. So what is v stack and h stack? So v stack and h stack is just a way to append things together. Consider this table A and table B and table C and table, means this we have 3 tables. With the help of h stack, which is horizontal stack, it will means combine 2 data frames or 2 tables together horizontally, whereas in v stack it is self-explanatory that it will join vertically, means it will append one data table or table over the other table. So that's what v stack and h stack does, and I will just show you an example of it. So we have these 2 arrays, A and array B. So I will show you what A and B does look like. Like we have defined the same thing over here, so it is correct. So if I append this vertically, as it says, A plus B gives you vertical stack. That means if you append or add 2 rows, it will provide you if you add single dimensions, then it will provide you two-dimensional rows, and the shape tells you that it is 2 rows and 3 columns. And if you append horizontally h stack, then it will give you one single array. It's just like extending a list. When we have seen that in list operations, how we add 2 lists and then it adds together and extending a list itself. So consider it in this way when you use this h stack. This is all about NumPy specifically. You may find you use this sparingly, but one thing to consider that be aware of things, how NumPy uses things, and means how You can use NumPy to calculate the basic task, and these all are very much useful when you're talking about NumPy. There are many more things that may be rarely used when you're talking about NumPy, but these all are the basics that you require to understand when you are working with data and data sets. It is rare that you use these operations as well, but these are the basics and you should understand the basics. That is what my aim and my goal is to with this particular practice. So let's begin with pandas. So in before that, I will try to means provide this particular Jupyter notebook whenever you are practicing with this code, and you also yourself try to maintain something other rather than just coming over here and means working on this Jupyter notebook, because everything is in front of you, so you won't means practice with yourself a lot. So one thing to note, that you start your practice with different notebook. Just use this particular notebook for the references purpose.